Okay, this is the video for graphing linear equations and inequalities. And so I'm going to do the starred problems. So this says graph on a number line, which means graph your solution on the number line. So you're going to solve just like you always solve, and then you draw a number line and graph. So we're going to subtract 7 on both sides here, and 12 minus 7 is 5. So you get the solution is x is less than or equal to 5. So when you draw your number line, here's 0 and here's 5. Then if it's an equal to, you just put a circle here at 5, a closed circle, because it's equal to. But this is an inequality, so you need to shade your number line one way or the other. So if it's less than, you're going to shade to the left. So anything less than or equal to 5 works. On the handwritten notes, I also put a bracket, because some people, when they draw them, they put a bracket instead of the closed circle, which is okay. I'll accept either one if you have a tendency to do this. People do that because if you're going to write it in interval notation, where you have you'd have negative infinity. Negative infinity up to 5 would be your in a bracket, because it's an equal to, that would be your answer. So if you typically use the bracket instead of an open and closed circle, then that's fine as well. So for number 4, we have x plus 19 is greater than 2. And so we're going to subtract 19 on both sides. So 2 minus 19 is negative 17. And it's greater than. So your inequality shows you whether to go left or right. So less than, go left; greater than, go right. So we'll say here's 0, here's negative 17. And so again, if you use circles, then it would be open because the inequality is strict. If you use brackets and parentheses, you would do parentheses since it's strict. So, and then it's greater than, so anything greater than negative 17 works. So you'd shade to the right. And so like I said, you don't have to do both of these. You would just put a parenthesis here instead of a circle, but that's just if you have a personal preference. If you have negative 1 is less than or equal to x minus 3 is less than 0, then we add 3 to everything. So negative 1 plus 3 is 2. It's less than or equal to x is less than 0 plus 3 is 3. So when we draw our number line this time, you have anything between, so here's 0, here's 2, and here's 3. Anything between 2 and 3, including 2 but not including 3. So we would have a closed circle or a bracket if you'd prefer the bracket on 2, and an open circle or a parenthesis if you prefer the parenthesis on 3. And you're done. So just remember, whether you do closed or open circle or bracket or parenthesis, strict inequality, it's the open circle and parenthesis. And if it has the equal to, it's closed circle and bracket. And then also remember, when you're inequalities, we didn't do any, but if you multiply or divide by negative, you flip the sign just like before. So we're going to jump to number 10, I think. Yeah, number 10. And for this one, I'm not going to write it again since you have this here that you can do. So we're going to do, you're going to plot these points and then determine if there's a relationship. And X is the amount of pressure and Y is the number of defective pieces of machinery. So instead of me writing all that out and taking a long time, we're just going to plot it here. So these are all positive, so we really only need the first quadrant for your graph. And I'm not the greatest at drawing, which you probably noticed if you've looked at the notes. I don't draw very straight lines, but it's okay. So here's my Y and this is my X. So we have Y goes from 0 up to 5. So I'm going to go 1, 2, 3, 4, 5. And then X starts at 50 and goes up to 100. And so what I did is I just scooted over some and put a 50 mark, and then I did by 10, 60, 70, 80, 90, 100. And then I went back and just put a little halfway mark between, well, they're not very halfway. That one's not very in the middle, but that's okay. So our points that we're going to do are 50, 0. So that means you go over 50 and up 0. So we have a point on 50, 0. 61, so we'll go over to 60 and up 1. And when you draw graphs, they don't have to be perfect. So like I said, mine's not perfect. 65, 2, so go over to 65 and up to 2, which is roughly about right there. When I draw lines, if I miss the point, I just make the point bigger. This doesn't have to be perfect. 73, so we go over to 70, so we got 50, 60, 70, and up to 3, which is maybe about right there. 84, so we go over 80, 60, 70, 80, up to 4, which is maybe about right there. If you make big points, then it looks close enough. 75, so we go back to 70, so 50, 60, 70, and up to 5, which is up here. 95, so we go up over to 90, which is here, all the way up to 5. And then 105, so we go over to 100 all the way up to 5. So this looks like it appears to be a positive relationship. If you were to draw a line, it appears they're going up. There's a couple, that are up here that aren't going up, but for the most part, this appears to be a positive relationship just by looking at it, which means as x increases, y increases. If it were going down, if you were coming down, then it would be a negative relationship, because as x increased, it would be y decreased. And then if you look back at number 9, that doesn't really have a relationship. They're just kind of scattered all over the place, so there's no relationship. But so you just want to see if just on a quick glance, if it's going up, it's positive, going down, it's negative. If they're just kind of all over, there's no relationship. So for the next ones, we're going to graph. So you want to graph, and it tells you for these first couple, we're going to use intercepts. So number 11, you have 3x minus 2y equals 6, and you want to graph using intercepts. So we're going to plug in for your x-intercept. That's always where y is 0. It's where it crosses the x-axis. Y has to be 0. And then for your y-intercept, you plug in a 0 for x. X has to be 0 because that's where it crosses the y-axis. So we're going to plug in a y0 to find the x-intercept. So we have 3x minus 2 times 0 equals 6. So this is gone. So we have 3x equals 6 divided by 3, x is 2. Or the 0.20. For my y-intercept, I'll plug in a 0 for x, so I have 3 times 0. And if you don't really want to write that down, you don't have to. Some people just don't write it down because it's gone anyways. But anyways, negative 2y equals 6, and divided by negative 2, I get y equals negative 3. So I have the 0.0, negative 3. So then, to graph any line, all you have to have is 2 points, and then you can connect those 2 points with a straight line, relatively straight. So I have the 0.20, so my x-intercept is 2, my y-intercept is negative 3, so go down 3, and then I graph. And if you really want to use a ruler and stuff, that's fine, but I don't do that. And then sometimes I'll try to write, I did on the notes there, I'll try to write what those are just to be clear. But so graph using intercepts, plug in your 0 for x, 0 for y, plot your 2 points and connect them. So one more like that, number 13. We have negative 2x plus 3y equals negative 12. So again, using intercepts, so we're going to do my x-intercept. I'm just going to stick a 0 in for y. And my y-intercept, I'll plug a 0 in for x. So for my x-intercept, I do negative 2x plus 3 times 0, so this is gone, is equal to negative 12. So negative 2x is equal to negative 12. So x is 6, or the 0.60, if you want to write the ordered pair. My y-intercept, I plug a 0 in for x, so I have negative 2 times 0 plus 3y equals negative 12. So again, this is gone, so 3y equals negative 12, so y, I divide by 3 is negative 4, so I have the 0.0, negative 4. So again, I'm going to draw my graph, plot those 2 points, and connect them. So my x is 6, so I have to go over to 6. 1, 2, 3, 4, 5, 6. So that's 6. And then my y is negative 4, so I have to go down 4. There's my negative 4, and then I connect those. And again, like I said, it doesn't have to be perfect. Just make your dot bigger if you miss a little bit. So if you have to graph using intercepts, that's all you do. Plug in a 0 for x, a 0 for y. And then I didn't do this, but just to mention, I didn't star these, but if you have y equals a number, that's always a horizontal line, because it doesn't matter what x is, y has to be 3. And then if you have x equals a number, like this one, it means no matter what y is, x always has to be 3, so that gives you a vertical line. So even sometimes people get it mixed up because x is the horizontal axis, so when you see x equals something, you think horizontal, but that's a vertical line, and y is the horizontal line. So for the next one, you want to determine, these are deals with the equations of lines, so you want to determine slope and y-intercept if you're given this equation. So the easiest way to do that is to write it in slope-intercept form, where you have y equals mx plus b, which is slope-intercept form. I'm going to write a slope-int form, but slope-intercept form, because m is always the slope and your b is always the y-intercept. So anytime you're asked to determine the slope and y-intercept, and you're given an equation, then you want to write it in that form, and you'll have both of those. So we have 5x plus 3y equals 6. So basically, if I want to find the slope and y-intercept, I just want to find, and I know we just said for the y-intercept, we could also plug in a 0 for x, which is equally fine. But to find the slope, I want to solve for y. So we want to get y by itself here. So I'm going to subtract my 5x. So I'm going to have 3y is equal to negative 5x plus 6. And I always write the x first, just so that it looks like this. And then we're going to divide everything by 3. So if we divide this by 3, we get negative 5/3 x. And then 6 divided by 3 gives me 2. So my slope here then is negative 5/3, because that goes with my x, and then this is my y-intercept. So my y-intercept, you can write y equals 2, or you can write it in an ordered pair, 0, 2, either way. So if you're asked to find the slope and y-intercept, solve for y, and whatever's with your x is the slope, and then the constant is your y-intercept. On this next one, you want to find the slope using the slope formula. So your slope formula, if you have 2 points, is m equals y2 minus y1, because it's rise over run. So y, the difference in the y's over the difference in the x's. So if we want it to go through 1, 3, and 4, 7. Now, most people call this one x2, y2, and this one x1, y1, which is fine. It doesn't really matter which one you call what, as long as if you start with this y first, you have to start with this x first when you do it. You can't flip-flop them around. That's usually the biggest mistake, is somebody will write 7 minus 3 and then do 1 minus 4 instead of 4 minus 1. So as long as you, whichever point you start with, you have to start with the x on the in the denominator. So we're going to go difference in the y's. So I'm going to go 7 minus 3 over 4 minus 1. So 7 minus 3 is 4, and 4 minus 1 is 3. So my slope is 4/3. So that's just plugging in your numbers. I didn't star these either, but be careful. Just make a note of this, because the other mistake, so like I said, the one mistake is you'll go 7 minus 3, but then somebody will write 1 minus 4, but that's not the same thing. So if you start with this one in the numerator, you have to start with this one in the denominator. And the other thing is, your formula has a minus, so make sure, like when you have negatives here, so I did 1 minus -6, so 1 minus -6, and I always usually put parentheses just to remind myself it's minus the negative, which becomes positive. So usually that's the other mistake, is the minus the negative. People lose that, minus the negative. So just keep in mind of that. If you have a negative point, you make sure to put parentheses around it or something, so you remember to switch the sign. So if you want to graph using your slope-intercept form, I'm not going to write all that, but we're going to graph using the slope-intercept form. So it gives us y equals 1/4 x minus 2. So that's our, we're right here, mx plus b, our slope, and our y-intercept. So our slope is 1/4, which means it's positive. So if your slope's positive, your line has to go up. If it were negative, your line would go down. So our slope's positive, we're going up. And our y-intercept is 0, -2. Your y-intercept is always whatever this sign is. If it's a plus, it's a positive. If it's a negative, it's a minus. So 0, -2. So if our slope is 1/4, this is our rise over a run. So that means we go up 1 and right 4. Or if you really want to go down 1, you can, but because it's positive, if you go down, you have to go to the left, because that's like negative, which becomes positive. So for positive slope, most people would go up and to the right. So we're going to draw our graph. So what we're going to do is we start at our y-intercept of -2, so I go down to 2, -2, which is here. Let me put -2. And then I'm going to go up 1, so I go up 1 and over 4. So 1, 2, 3, 4. So up 1 over 4, which puts me here. And I'm going to connect those. Oh, it's crooked, but that's okay. With a line, sort of. It's a crooked line, but that's okay. I don't grade based off just how it looks. So if you're given, to do it and graph using slope-intercept form, but it doesn't give you slope-intercept form, like let's say it said like, the x was on this side or whatever, you just solve for y like we did here, and then you graph that. So like if it said graph 5x plus 3y equals 6 using slope-intercept form, you would solve, and then you would say, okay, I'm going to start at 2 for my y-intercept, and then this slope's negative, so my line has to go down, so I'm going to start at 2, and then I'm going to go down 5 and right 3. For the next one, we have -8/3 x plus 4. So this one, it's already solved for me, so I don't have to solve. So my slope is -8/3, and my y-intercept is 4. So if my slope's negative, like I said, you have to go down. Your line has to go down. And if it's, most people for this, they would go down 8 and right 3, which is fine. If you really want to go up 8, you have to go left 3. So you have to do one positive direction and one negative direction to make the slope negative. So I'm going to start at 4. So 1, 2, 3, 4. There's 4, and then I'm going to go down 8. So I'll go down 1, 2, 3, 4, 5, 6, 7, 8, and then right 3. 1, 2, 3. So I'm at this point here. These ones are kind of far apart, so it's going to be Probably not going to draw it very pretty, but that's okay. Oops, I missed. See, so if I miss, it's okay. I'll just make the point bigger, and it's kind of hard to draw and film at the same time, but that's okay. As long as it looks like remotely close to mine, then that's fine. This out here was 3. And if you don't have, I didn't start this one, but this one, there's no y-intercept there, which means it's 0. So just start at 0 and go from there. But anyways, for the last one like this, we're going to do 6x plus 10y equals 30. So this one we have to solve for y first. So we still want to use the slope-intercept form. So we're going to subtract 6x. So 10y equals negative 6x plus 30. And then I'm going to divide by 10. Negative 6 divided by 10 reduces to negative 3/5. X plus 30 divided by 10 is 3. So my slope is negative 3/5, which means I go down 3 and right 5, or you can go up 3 and left 5, but most people go down 3 and right 5. And my y-intercept is 0, 3. So I'm going to start at 3. 1, 2, 3. And then I'm going to go down 3, 1, 2, 3, and I'm going to go right 5. So this is actually going to put me on an intercept, which is fine. And then I'm going to try to connect those. Probably not very well again, but oops. But there's my line. So now if you want to, instead of graphing, if you want to write the equation of a line, then depending on what it gives you, so write the equation in slope-intercept form. So we want to write it just like we were just doing, slope-intercept form. So for this one, it tells me the slope is 2, and it tells me my y-intercept is 0, 5. So if it gives you the slope and y-intercept, it's easy. Plug them in. So I'd have y equals, slope's 2, so 2x, plus my y-intercept is 5. So 2x plus 5. Now, if it tells me instead that my slope is 3, and it has to go through 1, 4. So now I don't have my y-intercept. I have my slope, but I don't have my y-intercept. So there's a couple ways to do this. I did it using point slope form, and I didn't think about the other way until just now. So I can show you both ways, that's fine. So point slope form is when you have y minus the y coordinate is equal to m times x minus your x coordinate. So what you would do is you'd have y minus my y coordinate's 4 is equal to my slope, which it gave me is 3, times x minus my x coordinate, which is 1. On this one, you have to be careful again because it's a minus, so if one of these were negative, it would be minus and negative, so pay attention to that. So distribute my 3, I have 3x minus 3, and then add 4 to both sides, I have 3x, and negative 3 plus 4 is 1. So there's my points or slope-intercept form using point slope form. The other way to do it is you have, let me put an or here. This isn't on the handwritten notes because I don't ever do it this way, but I don't know why I like point slope form for some reason. But anyways, I can write y equals mx plus b, correct? So we have y equals m, which we know is 3x plus, I don't know what b is, so I'll just write b. I know it has to go through this point, so I can plug in this x and this y and solve for b. So if I plug in a 4 for y is equal to 3 times my x is 1 plus b. So 4 equals 3 plus b. Subtract 3 on both sides, I get 1, oops, not plus, 1 equals b. So again, I would have then, write it in that form, y equals 3x plus b is 1. So you can pick whichever way you like. Personally, I'm a point slope fan, but that's just me. But you can also solve it this way, solve for b. So if it gives you 2 points you want to go through, so we want to go through 4, 1 and 6, 3. So for this one, I want to find my slope, which is m is equal to my slope form. So I'm going to do 3 minus 1 over 6 minus 4. So that gives me 2 over 2, which is 1. So again, you can use this point slope form, or you can use this, whichever one you want, and you can pick which point you use. So on the notes, I used point slope form and showed you on using both points that you get the same answer. And since I did that, maybe I'll do it this way on here, just so you see you get the same answer no matter what. So we're going to do this. So I'm going to have y equals 1 times x, which is just x, plus b. So then I can plug in either point. It doesn't matter. Pick one. So I'm going to pick 4, 1. So my y is 1. So I got 1 equals 4 for x plus b. So my b is 1 minus 4 is negative 3, which gives me the same thing. Y equals m, which is 1x minus 3, which is my b, which is also what I got here if you use the point slope form. Get it over here. If you use the point slope form, y minus 1 is equal to m times x minus 4. Using this point, you get x minus 3. Or if I use this point, I get x minus 3. Or if I solve for b, using this point, I get x minus 3. Or if I solve for b, use this point, I'll still get x minus 3. So there's several things you can do to do this one, and you always get the same answer, which makes you feel good, because anytime you get the same answer multiple times, you're probably correct. So for the last one like this, you want to go through 1, 6, and negative 1, negative 6. So for my slope, I'm going to do negative 6 minus 6 over negative 1 minus 1. And I could have gone the other way, just if you did 6 minus negative 6 is 6 plus 6, and 1 minus negative 1 would be 1 plus 1. So just be careful if you do the minus the negative. So this is negative 12 divided by negative 2, which is 6. So again, over here I did point slope form. So I did the y minus the y values equal to the slope times x minus the x value, and I get 6x. Or using the other point, so here's where I did minus negatives, using the other point. So y minus the negative 6 is 6 times x minus negative 1. So it switches all the signs using this point. So for this one, I'll do we have y equals 6x plus b. And I can pick which point I use. It doesn't matter which one, they both work. Most of you'd probably pick this one, and most of you, if you did it this way, would still probably pick this one, because it's all positive, and that makes, positive numbers are easier to deal with than negative numbers. So probably you pick this one. So I'm going to plug in a 6 for y. So 6 is equal to 6 times 1 plus b. So 6 is 6 plus b. Subtract 6, I get 0 is b. So my b is 0, so my equation is y is 6x. I would get the same thing if I use this point, which is what I also got over here. So lots of options for how to do those. So for our very last thing, you want to solve inequalities by graphing. So when I do inequalities, typically what I do is I get them in slope-intercept form, unless they're, I didn't star it, but unless it's a vertical line or a horizontal line, I get it in slope-intercept form, and then graph. So what we're going to do, solve for y. Same thing's true if we multiply or divide by negative. When we do this, we have to remember to switch the inequality. So I have negative 4y is less than negative x plus 4. So if I divide by negative 4, I have to flip this. So y is greater than negative 1 divided by negative 4 is 1/4. X plus 4 divided by negative 4 is minus 1. So my y-intercept is negative 1, and my slope is 1/4. And for an inequality, if it's strict, you have to do a dashed line. If it's an equal to, you have to do a solid line. So remember that. So I've got 0, negative 1. So I'm going to start down here at negative 1. And then I'm going to go up 1. My slope's positive, so I'm going to go up 1 and over 4. And it's strict, which means I have to do a dashed line. So there's my line. And this is negative 1, this is 4. And then there's two ways that you can decide where to shade. Because it's an inequality, just like on the number line, we have to shade. So if it's greater than, you shade above. If it's less than, you shade below. The only time that's not true is if it's a vertical line, and then you'd shade left and right. But anyways, so I usually do it that way just because it's quick. But so greater than, I'd shade up here. But you can also pick a point that's not on this line. So if 0, 0 is not on the line, you always want to use it because it's easy to plug in zeros. If it is, if it goes through the origin, you have to pick another point. So pick a point that's not on the line. We're going to do 0, 0. So I'm going to test 0, 0. So if I plug in a 0, I can plug it in here, here, or here. It doesn't matter. I'm just going to plug it into the original. So 0 minus 4 times 0 has to be less than 4. 0 is less than 4. This is true, which means I shade the region that's got 0, 0 in it. So I still shade above. If it's false, I shade the opposite region. So I'd shade down here. So for our last one, we have negative x, this is number 39, negative x plus 5y minus 10. So again, I'm going to solve for y. So is less than 0, sorry. So I'm going to solve for y, so I'm going to add 10, and I'm going to add x to both sides. So I'm going to have 5y is less than, becomes positive x plus 10. Divide by 5, I don't have to switch the inequality since it's positive, so I'm going to have 1/5 x plus 10 divided by 5 is 2. So here my y-intercept is 0, 2, and my slope is 1/5. So draw my graph. I'll go up to 2. And then my slope's positive 1/5, so I'm going to go up 1, and then over 5 here. So I'm going to go up 1 over 5, which puts me here. And again, it's a strict inequality, which means I have to do which means I have to do a dashed line. If it had the equal to, I would do a solid line. For this one, less than, I'm going to shade below. But again, if you want to check it, 0, 0 is not on the line, so I can use 0, 0 again. So if I check 0, 0, I get, it doesn't matter which one you plug into. I'll plug it into this one this time just to see. 0 is less than 1/5 times 0 plus 2. 0 is less than 2. This is true, so I shade the region that has 0, 0 in it. If it were false, I would shade the opposite region. So that is all for graphing linear equations and inequalities. Please let me know if you have any questions.